Here's a review on how to factor polynomials. It'll be a brief general review, and then we'll get into some multi-step problems. By the way, this should probably say worksheet, worksheet 10.7 on it. Alright, so factor out the common factor of each expression. So I'm going to actually skip over to number 2. Is there a number that goes into all these numbers? I believe 8 is the biggest number that goes into all of them. Yeah. So I'm going to factor out an 8, although notice they're all negative, so I'm going to factor out a negative 8. That way I have positive values in the parentheses. And then is there a variable we can factor out? Well, they all have n's, which means I can factor out an n. And then to do the greatest common factor, you have to look at the smallest exponent and factor that out. So I'll factor an n squared out. To figure out what gets left in the parentheses, essentially we're creating a distribution problem. Our answer will be a distribution problem. And when we distribute, we should get what was originally typed in here. So when I divide negative 64 by negative 8, I get 8. N squared divided by n squared. The n's actually cancel out. And then negative 16 divided by negative 8n squared gives us a positive 2. Now subtract your exponents when you're dividing the same base. So n squared. Negative 56 divided by negative 8 is positive 7. Subtract your exponents into the fifth. Here, look for number 1, look for the greatest number you can factor out. And then notice that there is no variable there, so you can't factor out an n here. So that's GCFs. By the way, when we're trying to factor any polynomial, we always look for a GCF, like we just did first. Okay? So factor these things as far as we can completely. So looking at number 3, I do not see a greatest common factor. There's 1's in front of these, so I could factor out a 1, but that's no different. And then this doesn't have a variable, so I can't factor out a variable. So then I'm asking myself, how many terms does it have? 1, 2, or 3? This has 1, 2, 3 terms. Excuse me, it's either going to be 2 terms, 3 terms, or 4 terms. The one that we're looking at has 3 terms. Then look if the number in front of the x squared is equal to 1, we can do this top easy method. And it is. Awesome. So we're going to make our diamond, and the negative 20 goes on top. We're looking for ways to multiply to negative 20 and add to negative 1. So look at your factor chart. It needs to be 1 positive and 1 negative. So negative 5 and positive 4 multiply to negative 20 and add negative 1. Because we're using the easy method, we just take these solutions and plug them in after our factored form. Boom. All right. Number 4. Is there a GCF, first of all? This one doesn't have an A, so I can't factor out a variable. And I can't think of a number that goes into 2 and 7 and 72. So there's 3 terms, but my coefficient of the squared term is greater than 1. So I'm going to have to do this other method where I multiply A times C, and that's what's going to go on the top of my diamond. So careful, that's a negative 72. So I get negative 144 on the top of my diamond and negative 7 on the bottom. So numbers that multiply to negative 144, that means that one's positive and one's negative, and then it's going to add to negative 7. Nine and 16 I think would work. But the 16 needs to be negative. Yeah, that does multiply to negative 144. It definitely adds to negative 7. So here's the deal. Because we had to do this AC method, we're excited to find this correct pair, but we now use that to split the middle. Instead of writing negative 7a, I'm going to write positive 9a minus 16a. And the 2a squared comes down in front, and the negative 72 goes at the end. So now we do factor by grouping. The third term is negative, so I need to add the opposite to address the fact that that third term is negative inside the parentheses. So now we just do GCFs of each of these groups. So I can factor out an a out of the first one. So I get 2a plus 9 then once I pull an a out of each of these terms. What number can I factor out of these two? I believe a negative 8. Now I said a negative 8 because I actually want this parentheses right here to look exactly the same as that one. And if I factor out a negative 8, I get a positive 2a and a positive 9. If these two parentheses, what's inside of them, match, then we can simply put our GCFs together, our a and our negative 8, and multiply that with our 2a plus 9. And if you were to FOIL this back together, you would get what we originally started with. Now, remember our chart here. So we're going to always look for a GCF. The process that takes a while, that's quite a bit of a process. This process that takes a while, it looks like maybe we'd have to use here because my leading coefficient is not 1. However, folks, always look for a GCF. Whoa. Yeah, we have a GCF here. It's 5. So divide everything by 5. That means in the parentheses I get r squared minus 9r plus 8. So now we try to factor what's left in the parentheses. Is that factorable? How many terms are there, first of all? There's 3 terms. And my leading coefficient now in the parentheses is 1. So I can do the easy diamond method. So multiply to 8 and add to negative 9. So negative 1 and negative 8 do that. So we get r minus 1 and r minus 8. If we were to FOIL this part together, we would get the polynomial that I've highlighted up in green there. However, folks, realize that that's not actually my original polynomial, it's this one. That GCF that we have out in front here, we need to pull down with it. So this is my final answer. If I multiplied all of this together, I would get that up there. Let's try another one of these. I can factor a 6 out of these. And that's awesome because now I have my leading coefficient gone. So a 6 is out in front. K squared minus 2k minus, well, 48 divided by 6 is 8, so it must be 80. So now we look to factor what's left in the parentheses. We want to factor this completely the directions say. So can we go any further here? So we're looking for numbers that multiply to negative 80 and add to negative 2. So one number will be negative, one number will be positive now. That's how we multiply to a negative number. And really that means that they're only 2 away. So 8 and 10 are 2 away, and the 10 has to be negative. So to factor what's in the parentheses, we would have k plus 8, k minus 10. And bring your 6 down or your GCF down out in front. Try the next two on your own. I'm going to now switch to here. So here, let's look for a GCF. By the way, just a quick recap. Oh my gosh, there's only 2 terms there. Is this a mistake? Remember, we can factor things with 2 terms. We have to be able to square root both of the terms. If both of them are perfect squares, we square root them. The square root of the first term goes at the front of each binomial, and the square root of the second term goes at the back of each binomial. We have one with addition and one with subtraction. So let's try that here. First, let's look for a GCF. And by the way, like right now, I can't take the square root of 18, so I can't use that method that I just reviewed with you. But I can factor a 2 out of each of these. So when I factor a 2 out, I get 9n squared minus 16. Hey, I can square root both of these terms now. So because I can square root both of them, I know that my answer will look something like this. And what goes in the front here is whatever is the square root of that. So the square root of the first term, 9n squared, is 3n. So I've got 3n and 3n. And then whatever goes at the back is the square root of 16. So you get 4 there. So we have plus 4 and minus 4. Let's try that over here. By the way, so this is the final answer. And that difference of squares, if you think about what I have highlighted here and highlighted here, if you were to FOIL this back together, you'd get 9n squared. You get a negative 16. You'd also get a 12n with this multiplication and a negative 12n with that multiplication. So that 12n and negative 12n cancel out. That's why there's no middle term. To look at that one more time, is there a tougher one besides tougher than 10? I don't know. I'll do number 11 instead. So number 11, there's no square root or perfect square. 98 is not a perfect square. So let's see if we can factor something out. I think 2 goes into both of them, and I like that because then I get 49x squared and 25. So I can square root both of those new terms in the binomial. So square root of 49x squared is 7x. Square root of 25 is 5. But then we add and subtract those. I'll be a rebel here. I'll put a minus sign there and a plus sign there. When you multiply or FOIL this back together, you get 49x squared minus 25. All right, let's try these. Is there a GCF? Yes. We can factor a 5 out. So we get 5 parentheses 2n squared plus 21n plus 49. That seems right. So now, folks, we try to factor this in parentheses even further. So we have to think about what method should we use. Well, there's 3 terms here, but our leading coefficient is greater than 1, so we have to use the AC method that we looked at before. So numbers that multiply to 98 and add to 21. So I think both numbers will be positive here. I think 7 and 14. Multiply 98, yep, and they add to 21. So because we're using the AC method, it's not as easy as just finding those. Now we have to do factor by grouping. So we rewrite 21n as 7n plus 14n. The 7's positive, so I'll put a plus sign in front of it. And now we group up the first 2 terms and the last 2 terms. So factoring, we can factor an n out of the first 2. Try to factor out a number as well, but you can't here. Whereas here we can factor out a 7, but not an n. So we're left with 2n plus 7. So now that our binomials match, that's good. We put our GCFs together, which really means we're actually kind of factoring out an n and a 7 from each of those. And then we have 2n plus 7. Don't forget to bring down that 5. It's all getting multiplied by 5. Just comes down. If you multiplied all this together, you would get what we initially started with. I think that's all the time I have on this.